So welcome to the live launch of the DKG Explorer that's been up and coming for a while. We're very excited to show you guys how everything works. Rana, did you want to kick it off with or do you want me to share?
Yes, I will share. Hello, everybody, also from my end. So today we'll be looking at something quite interesting. I guess the two of us will be presenting. Feel free to leave your comments in YouTube and wherever you feel like it, Discord, Telegram, and places where the community hangs. And yeah, Yuri, I guess we can quickly introduce ourselves. Yuri is the general manager and one of the people who's been leading the adoption and implementations of OriginTrail primarily with large enterprises. He will be showcasing some of those examples today. And myself, I'm Vladimir. I'm one of the founders and the CTO of Trace Labs, core developers of OriginTrail. So today we'll be speaking quite a bit of interesting things. It's going to be a packed demo with a lot of exciting details to cover. So without any further ado, we're 5 minutes in. We're just going to start with a quick introduction. And all I'll need from you, Yuri, is a thumbs up that you can see the screen.
We can see the screen.
And that's awesome. So welcome again, everybody. We're going to be speaking about the latest release of basically a major tool in the OriginTrail ecosystem, the refreshed and reborn OriginTrail DKG Explorer. And what that is, we'll dive into just now. But for some additional and really high-level context, we are going to start with the problem of why OriginTrail is here at all and what we're trying to do with this open source, decentralized and permissionless technology, and why in that particular way. So I'll just quickly remind you of this guy. You've probably seen him all over the news the last couple of months, the godfather of AI, who actually gave a resignation in Google because of the dangers that are ahead of us, especially with the rise of AI. Basically, he's named the godfather of AI because he's the creator of the newly expanding neural approach of AI, and has been actually so deep in this research that he has discovered quite a lot of problematic situations, specifically of such technology being able to cause harm with actually very convincingly generating misinformation. And that actually happened to a lot of people already. One of them was a certain lawyer from the US who, I guess, did legal research and had to rush it maybe a little bit, probably without some bad intent, who seems to have used ChatGPT to essentially cite a bunch of non-existing cases in his filing. Probably has seen ChatGPT say very authoritatively, "Hey, this is the right thing. You should post in," and actually the lawyer got into a lot of trouble. So this is a very simple, probably most likely benevolent or essentially non-ill-intended case of misinformation just seeping into our daily lives and work. And it's been happening before AI as well. So there's been a lot of different problems. I'm sure everybody's aware of things like fake news and propaganda has been always around. So the actual ability to distinguish what is information and misinformation has always been a problem, and especially with AI now generating additional content nonstop and with an exponential pace, at some point in the future, probably very near in the future, will outpace the amount of human content being created. It can pose quite a bit of a problem. So in a world of misinformation where it's overflowing, trusted data really becomes the cornerstone of security and prosperity of the entire humanity. And that's a problem we've been trying to tackle throughout different applications with OriginTrail for a very long time now, and it's become much more apparent and even much more problematic with the rise of the technologies that we have lately. However, we're not saying here AI is all bad and you should not use it and whatnot. Actually, we have quite a contrary opinion. We should embrace it, and the way to embrace it is to actually build solutions with AI and trusted data together. And today we'll show one important component of these solutions, actually a couple of them, through several demos. So super excited to get there. But just on one more point, when it comes to the importance of this particular moment, we might not realize how big of a change is happening. And we'd argue that the change is as big as essentially a completely new knowledge revolution. And knowledge revolutions, essentially, we've had a few over the course of history, obviously the invention of writing being one, but one of the sort of big recent ones that was very well recorded in history was the knowledge revolution that was basically kicked off with the invention of the printing press. So Gutenberg basically created a printing press, solved the problem of scarcity via replication of knowledge. And what happened is literally a renaissance. So the knowledge prior to that was basically brokered and kept by institutions such as the church. It was handwritten, hand copied. Not everybody had access to it. And when it got democratized dramatically with tools such as the printing press, the whole world changed. And I mean, I'm sure you guys know what happened with the Renaissance. It's been a tremendous transformation of society. Then another one was with the internet, where we basically solved, in a way, the problem of fragmentation. The problem of fragmentation was we had a lot of knowledge everywhere, but it was hard to connect it. Getting into computer networks such as Ethernet, Internet, and then the World Wide Web, which is more of a web of knowledge, of data, rather, connected websites, essentially, that you could traverse as a kind of a unique web graph with www, invented by Tim Berners-Lee, and the networks below, one of the inventors being, for example, Bob Metcalfe, which is one of our advisors. These guys have actually tackled the problem of fragmentation, and all of a sudden, boom, we have like instant sharing of content, whatever type of content that is, information or misinformation globally, very quickly. You can text people across the world in a heartbeat. And obviously, with that increase of throughput, we get a problem of trust. And the problem of trust is obviously something we've been handling for quite some time. If you're in the Web3 space, you've been focusing on trust for sure at some point. And what we see that this particular primitives that Web3 and OriginTrail offer are really well suited to help basically infuse AI with trust by enabling essentially a decentralized AI approach. So we believe this is the third revolution that we're entering right now, which will be over on the magnitude of the previous revolutions that we have highlighted here. So buckle up. It's going to be a very interesting couple of years and decades ahead of us. The world is going to change tremendously. And if we, as good actors in this world want to change it in the right way, we need to build solutions in the Web3 sense with capabilities that come from the new technological advancements, but in all industries, AI, blockchain, and others, but also making sure that all of this comes with the utmost maximum level of trust and the principles that go with it, such as transparency, open source, and open development, basically permissionless access and neutrality, inclusiveness, and usability overall. So essentially, we are here to claim that knowledge is a new asset class, and OriginTrail helps you seize it. It's not hard to see this already happening, that knowledge is generating immense value for Web2 companies, especially. So if you observe companies which are not even in the AI space, such as Google, Netflix, Amazon, actually all of them aggregate a ton of knowledge using knowledge graphs, by the way, which is one of the core components of OriginTrail, and essentially collecting a lot of knowledge, organizing a lot of data together, and getting a lot of value from it. Value that's being used to either increase engagement, increase sales, or just generate a lot more awareness depending on which product you look into. But not just the Web 2 products. If you look at ChatGPT, for example, amazing new tool that basically took the world by storm, which was trained on all of the scraped data from the internet that was organized as knowledge. And in that sense, without this knowledge, this value wouldn't be created. So the knowledge that is used to train or to extract information from is very valuable, and OriginTrail makes it possible for you to create knowledge assets out of the knowledge that you create, curate, gather, essentially using the technologies of these big giant companies that made it in Web 2. You can use the same technology in open source Web 3 way to do the same for your business or you as an individual even. So today we'll show you some of that in very, very deep details. And it might get a little technical. So if that's too much, do not worry, but also feel free to ask any questions, jump into our Discord or Telegram, and where we'll be, including the OriginTrail community, will be very responsive. It's one of the most welcoming communities, I would say, especially around Web3. So what is OriginTrail? Like I said, it's a combination of knowledge graphs and blockchains. And on a very simplified level, you can observe it as this 3-layer infrastructure. So we have the multi-blockchain consensus layer, the layer 1 of OriginTrail. The layer 2 is the decentralized knowledge graph, where all of the knowledge is kept. And then knowledge asset applications that come on top. So essentially, we're talking about a multi-chain decentralized knowledge graph, and it's composed of something called knowledge assets. All of these knowledge assets have verifiable data origin and information trail. It's been launched in 2018 as the first decentralized version of OriginTrail on Ethereum, expanded to Polygon, Gnosis, and Polkadot actually last year. And like I said, it's a completely permissionless system where blockchains are used as a trust layer, and the decentralized knowledge graph, or DKG, is really this semantic knowledge layer. So what are these knowledge assets? Essentially, knowledge assets you can essentially understand through the several value propositions that they bring. The first major thing you can do with knowledge assets is basically you can create and own your knowledge. And when you create a knowledge asset, which means you actually create, you take a certain piece of knowledge, you also wrap it with a unique NFT. This NFT, or non-fungible token, for those who haven't heard about this abbreviation before, actually is used to represent the ownership of this knowledge. And with the representation of ownership of knowledge, we also enable many different capabilities, such as exposing this knowledge to a market, but also outside of just marketing or sharing it, it's also possible to apply various different access controls, or rather administrative controls. For example, if I create a knowledge asset and I put some knowledge inside, I will get this NFT minted in my wallet, as you can see on this animation. And as long as I have this NFT, I can actually manage this knowledge asset. That means I can update it, I can expand its lifespan, because knowledge assets have also a lifespan. I can transfer it to somebody else, for example, Yuri. I can attach it to a marketplace. I can do many different things. And under the hood, it's basically all based on a standardized ERC-721 NFT. When I create knowledge assets, I also make them discoverable. So discoverable knowledge assets means that they are all part of this big decentralized knowledge graph. Meaning it's a public decentralized index of information of knowledge assets. However, that doesn't mean that all of the information in the knowledge assets needs to be public. So there, you could also create knowledge assets that have private components of information that stay within the domain of your knowledge bank or knowledge vault. However, the public index really is there to make these knowledge assets discoverable. That means very much in the same way as Google indexes websites. So you can do Google searches and discover content on the web. You can do and build similar search applications or search engines on top of OriginTrail, because the public decentralized network essentially acts as a decentralized index. And then you can go and explore all of this knowledge. This is obviously very simplified. There's a lot of ways you can discover knowledge in the DKG, and we'll show you some of that today with the DKG Explorer. The third value proposition is verifiability, very important one, which is the key for trust infusion in the knowledge that we're looking at. What does verifiability mean in this case? Well, basically, every knowledge asset has a known information provenance. So we know exactly for each knowledge asset who created this knowledge asset, where does this knowledge come from, essentially, who was the issuer, as well as what all has happened with this knowledge asset over time. So if I create a knowledge asset, you'll see that it was me because of the actual issuer key or public key, the wallet, or whatever you want to call it, is visible and it's all on a public blockchain. If I transfer ownership, you'll see those transactions. If I have updated this knowledge asset, you'll see every basically detail about this operation, such as timestamps, who did it, and basically if you're a developer, for example, you can consider it as kind of a trusted Git branch with Git commits over a piece of knowledge. If you're not a developer, think of it as kind of a verifiable trail of any change that happened with this particular knowledge. Why is this useful? Well, because with verifiability through this transparency, you're able to establish exactly where the information comes from, what has happened over time, has it been changed, and then you can actually make decisions on if you want to use this information or not, and in what way do you want to use it. That can be a decision that's implemented in some code, or it can be decided upon by certain, let's say, AI, or it can be a human decision that you decide to make. And various different things can be implemented on top of these three value propositions. However, with all of them together, essentially, knowledge assets become AI ready. So what does that mean? You can essentially take this knowledge asset, package it in the way it is, and use it very easily in different AI systems. For example, you can create trusted chatbots where you can ask certain questions and get responses that come from trusted knowledge assets with a trusted source, which are basically verifiable, discoverable, and ownable. And this is just one of the examples, which we'll basically show you in a minute. So with that, in a little bit more detail, knowledge assets are comprised of four things. Basically of the knowledge, which is this graph of information structured according to certain standards, actually called semantic web standards. The second part is the uniform asset locator, which is essentially the URL of Web3. It is a trusted, decentralized identifier that you can use to actually discover and ingest a knowledge asset. And basically, it's comprised of a blockchain identifier and a graph identifier. So there's no need to trust any party or even a DNS-like system, which is centralized. We can rather basically use your own computer is able to actually fetch the right records from the right decentralized network, such as blockchain and the DKG. And with this information from chain, which is the knowledge state proofs, like I mentioned, the changes of the state of the actual knowledge asset, and the knowledge NFT, you can basically encapsulate the entire knowledge assets. So you can ingest the knowledge and you can compare that the actual knowledge is exactly the same with the exact same knowledge fingerprints, the hashes that are on the blockchain, because you can always recompute the hash of the knowledge and compare it with the one on the chain. That means this system is much more scalable than just using blockchain, because you can fit an arbitrary size of knowledge, but also the knowledge doesn't require consensus as a bottleneck to actually crunch around. Rather, the knowledge is kept on the decentralized knowledge graph, while its provenance and ownership is essentially embedded in a blockchain. And like I said, all of these knowledge assets are connected, and we'll see that in a moment, in a very big DKG index. If you're a developer, again, let's say you're building something with your JavaScript, for example, we have a JavaScript SDK where you can very easily create knowledge assets. You would just instantiate the DKG client, essentially, and you can do the DKG assets create method. You would use it to create knowledge assets by providing a graph. Then once you do that, you actually get the URL, because you minted the URL, essentially. You can get or fetch the knowledge asset from the network. And by the way, whenever this is done, the actual verification is done automatically. So your application is completely protected from any potential change in the knowledge along the way. That means, let's say, man-in-the-middle attack, or man-in-the-middle attacks or similar problems that might occur. It's not possible because your client will protect you. You can also update knowledge assets if you're the owner. So you have to be the owner of this. And if you're not the owner, you can transfer. If you're the owner, you can transfer the ownership. You can also get the owner. But you can also do something very interesting. You can actually query the knowledge graph. So the DKG, the entire knowledge graph, you can essentially sync it just like you sync a blockchain, and you can run these things called Sparkle queries. And I can actually show you a very brief Sparkle query. So we're getting to that point in time where we show the demos. So literally what you just saw, I'll show you in code. And here it is. So this is a very, what's happening here? Okay. So this is a very simple JavaScript file where I basically instantiated the DKG client. And I'm not going to create any knowledge assets now or really get them just for the sake of time. I'm just going to show you two queries. For example, I'm going to show you the first query here is a Sparkle query, which basically selects the documentation in the graph that has the name of OriginTrail. And I actually have this wrapped in a function called query white paper data. So I'm going to just going to run it with this simple Node.js script. So essentially it's query demo.js. And it's not going to be very revolutionary. What I'm going to essentially get back is a result of a Sparkle query. So what we're seeing now is knowledge graph, basically a classic query. Just as if you were to query, let's say, your SQL database, you can query the decentralized knowledge graph. Same language, no need to do any special, changes. And we can see, for example, in this case, for this query, we see that there's 3 documents that have been labeled with the documentation tag. So this is OriginTrail official docs, the ecosystem white paper 2.0, and the first version of the white paper. Another, for example, query you can do with the same script, I'll just uncomment it, is an example of construction data. So we're going to look for every single building that basically is in this street in Slovenia, which is Prešernova cesta. Might sound a little rough on the tongue, but trust me, that's how it's pronounced. So I'm just running this query again. So what this is doing is actually I'm querying with the DKG client, I'm querying the DKG itself, and actually I'm getting a bunch of buildings and their identifiers, and I can use that to build, for example, applications such as search applications, query applications, and so on. So it's actually very easy to do that. And right now I've been demonstrating basically the JS client, but there's a bunch of clients in the works, and I'm happy to announce today that we'll be very soon sharing the beta version of the Python client. So whoever's been looking to build with the Python client with tools such as LangChain and prefers the Python way, you'll be able to do that very, very, very soon. Okay, so that's the first piece of the demo. This is how we would do it with code. Now, the second part of the demo, which is really the cool stuff today, is actually built with this and is going to be showcased to you by Mr. Yuri. So I will let you take over.
Thank you, Branimir. And it's actually really nice that you did this with OriginTrail documentation, because, and I'm just going to quickly share the screen and you guys let me know if everything is visible. Just a thumbs up.
Yes.
All right, so let me just get rid of all right, fantastic. So what we're seeing here is the new and refreshed DKG Explorer interface, which is a window into the knowledge asset that live on the version 6 of OriginTrail. And it's a very simple interface to get started with. So you can search by a UAL, so the Universal Asset Locator, what Branimir mentioned before, or a wallet address. There are some examples which we'll look into in a second that give you a bit of a feel as to what are the different applications of knowledge assets across different industries and sectors. You can see the latest activity on the DKG, some statistics around knowledge assets, total graph size, and of course, the main part will be the actual exploration of knowledge assets. So Branimir was just showing a query for OriginTrail and the white papers and whatnot, which is one of the examples that we have here under scientific research. So you can click on it, the URL will get populated in the search, and you can search. And what happens now is, and I'm going to zoom in a little bit, is that we actually have a knowledge asset, which is the organization of OriginTrail that has just loaded, and you can see a couple of things here. So one of the things that, or one of the value propositions that is really important was that each knowledge asset is actually ownable. So somebody owns this knowledge asset, and we can actually click on this NFT link and see on the blockchain page who this NFT actually belongs to. So you can see who the owner is. You can see the details around ownership transfers and whatnot. So this one hasn't had any ownership transfers. So you can actually verify this ownership on blockchain so that you can always be certain where this particular piece of knowledge comes from. So I'm going to close this. So you can do this for every knowledge asset. And as we're looking at this, there are a couple of things we have on the screen. We have the graph. Let me just hide these thumbnails. So we have the graph exploration interface on the right, and we have the knowledge asset profile and status updates cards on the left. On the actual knowledge graph exploration, we have a couple of icons I just want to mention so it's a little bit easier to follow. We have the hexagons, which are knowledge assets. And you can see here we have this knowledge asset, which is OriginTrail selected, but it's connected to a variety of different knowledge assets, which we'll look into in a little bit. So this is really where that connectivity comes into play. And then we have within the knowledge asset, which is essentially a container for verifiable data, we actually have then resources. So resources which are marked with these little white circles with a blue outline, and of course the blue dots, which are essentially properties of these resources that are contained in knowledge assets. So for example, we have a knowledge asset, which is the OriginTrail.io, represented by the OriginTrail.io website, and some parameters, basic parameters around founding date, the contact email, the description. All of these you can explore either through the visual interface here, or if you want to look into it in a bit more, if it's too long and you want to look at the content in a bit more structured way, you can actually have all of these resources and their parameters in the card, and actually you can even have a broader way of exploring, so we can see the description nicer, you can see the email, you can see what documentation we have, the URLs, so everything, all of the properties, so all resources and all their properties you can explore also through this or the visual way. Now, that was the first value proposition that we had, ownership. The second one being the discoverability and connectivity, and this is where we'll really see the power of how the graph functions and how the graph grows. So if I take, for example, one knowledge asset that is connected to the OriginTrail one that we currently have in focus, is that it says here that we have an advisor, who is Robert Metcalf. And more details about Robert Metcalf are actually in this knowledge asset, which I'll click on now to resolve. And as you can see, there's a lot of information going on. So I'm going to zoom in a little bit closer so we can see we have this knowledge asset, which again has its own owner. We can click here to find out. We can see the details about it. We can see that this is Bob, alternate names, all that that is contained in. But for example, if we wanted to continue exploring and see how all of these connected assets kind of form a graph, we can have a look at, for example, what Bob knows about. So if I pull this up here, Bob knows about a lot of things, obviously. One of the things he is most famous for is actually Metcalfe's law. And we can see that he's connected to Metcalfe's law, and we have some additional information on that law in another knowledge asset that is linked to this one. So we're going to open that particular piece. And I'm going to zoom in just a little bit so that you guys can see already how much of how much of this connectivity and knowledge assets already we have just by opening up a couple. And you can see we have many linked knowledge assets that are still to be opened if you feel like exploring further. And the last thing I'm just going to do is we have here the knowledge asset, which is Bob. So we can see Bob, Metcalfe's law. And then we have here claim review, which means that there are a bunch of articles that talk about Metcalfe's law. This is really where then scientific research comes in, because you can have a lot of connections, a lot of different papers indexed here that you can then use as basis for your AI system, for any type of other search. And one of them, for example, you click on one article in Science Direct, and we can open it. So there's a lot of stuff already here, and we can see actually if I just click here for ease of reading. 1 second. So we have the property. We can see actually more details about this particular scholarly article. We can see the abstract. We can see where it is. We can have the URL to the actual article so that we can open it. So the source is indexed, and so on and so forth. So if I zoom out now from this particular example, you can see we opened, I think, only 4 knowledge assets, which all of them have ownership, all of them have verifiability, all of them have the third characteristic, which we can actually see down here. I mentioned verifiability, but this is the one that we haven't had a look at, where you can have status updates for each of the knowledge assets that you can see on the screen. So you will see who created it, when it was created, anytime the asset was updated or ownership was transferred. This is what it will show here, and it will also show a state hash for that particular let's say state of knowledge assets, so that you can always verify whether what you're looking at on the screen is what is actually fingerprinted on the blockchain. So that's kind of one of the examples, which was the scientific research, and you can see we really have a huge web of knowledge assets that we haven't even opened yet. But for the sake of diversity, I'm going to go back to the starting page and let's look
Yuri.
into. Yeah.
Let me jump in with just a quick comment while you do that. I think you didn't forget anything. I just wanted to it looks really great to see all of the basically composability of knowledge assets here, and that's the key value proposition that is brought by knowledge graphs. So this is essentially enabling all kinds of different information, people, documents, social media content, pharmaceutical information, all kinds of information you can have living in the same thing, in the same environment. And that's traditionally quite challenging. If you're looking at all of the data providers around the world, you traditionally would have databases that have some rigid structure or are tailored to some certain system. Knowledge graphs actually enable you to connect all of these things. And when you can connect them, and when it's so flexible to get things and basically compose a large graph of knowledge assets with it, that basically means we can all collaboratively create a huge knowledge base together. So as long as we know the owner and the issuer of the information, we can always navigate the graph and decide in our applications or systems or as humans what we can do with them. And by the way, what you're seeing here with the DKG Explorer is, if you're familiar with the notion of, let's say, a blockchain explorer, this is a very similar type of generic application on the DKG Explorer. So a lot of this knowledge has potential to be both displayed but also used in a more specific way. For example, if you're looking at documents, or posts on social media, you can consider a bit of a different visual representation of them for each of them. But this interface, the idea of it is that it generically enables you to connect and see and explore all of them. And it's this connectivity, as you mentioned, or composability, that really enables this network effect to happen, where we can connect all kinds of things and they bring value to each other, essentially. So yeah, just wanted to add that. Please keep on going. I think this is a really cool demo.
Yeah, thanks for adding that. I think that's an important piece. Also, we'll kind of see here in a bit of a different industry So this example is from the life sciences and healthcare industry, which looks at a fictitious drug that we were working with within the scope of the Sustainable Medicine Partnership to be able to showcase such demos and examples so that you can see how it works. And this is a knowledge asset that essentially represents master data about the product. So the description, what the product is. So we can see this is Umakerol, the name, 500 milligram tablets. We have the GTIN number here. We have the description over here. So we can also, the same as before, explore this in a list of resources on the in the side menu. So this medicine is Umakerol. It belongs to painkillers and all the things that are related to the master data. What's interesting here is we also included a demo version of the digital link here. So this is actually represented, as you can see, by a digital link identifier within the knowledge assets, so that it's then easy to use also on labels and finding or scanning items and being able to be redirected to, for example, an interface that we'll see a little bit later. But in a similar concept, we have this knowledge asset, which is talking about a product, and we can see it's connected to a bunch of other knowledge assets. And if we look at, for example, this one, it's connected to a lot of that particular product as well. And when we open it up, we see, okay, this is a lot, over here, this is lot ABCD. It has this master data, and we can see even further now that this particular lot was a part of some event, because we can see here that it was used in something. So, and that's contained in another knowledge asset. So we open that knowledge asset up, we will be actually able to see an event, a patient administration event, essentially, where this particular lot was administered to a patient for a certain treatment post surgery. Just a second so that this opens up. So we can see that this is an EPCIS document, so EPCIS event. And let me just find it. So we have it over here. We can see actually, so this is the event. We can see that what product was used. So it's the product that we looked at before. So the lot of that product. How much of it was used. We can see all of the details, also where and when. And then we can also see treatment details here that talk about what was this particular event treating. And we can go on. This is also connected to a patient, where we can have more information in a separate knowledge asset to a patient. So again, we're growing essentially the number of knowledge assets that are connected and can be resolved. But there is one nice thing I left for kind of opening last, and that is if we return back to, and let me just quickly find that. This is the lot, this is the event, so it will most likely be, let's do not. Very quickly find it. There's a lot of them open. Okay, so it's over here. So we have, where is it? Over here. So EPIL, which means electronic product information leaflet, which is also connected to the master data of the product. And here I can actually open this knowledge asset that contains this product information leaflet. So all of the the leaflet that you get in the pack, but you never read, but you probably should, especially if the drug you're taking is of a serious nature. So this is also one of the knowledge assets that one of the things that is packed in a knowledge asset, and we can see here different sections and different subsections around what this of that actual leaflet. So we have, again, all of these knowledge assets which talk about very different things in a way. So we're having supply chain events, we have product information leaflets, we have product information, we have patients potentially. All of them are connected in this web of knowledge assets that we see here. All of the knowledge assets could come from different issuers, different owners, and still be connected in exactly the same way. And this really then serves as that trusted knowledge foundation that you can use with any AI system. And this is something that that I wanted to show as kind of the finishing touch to this. So we have all of these assets. they're very connected, they're verifiable, that you can find them, they're ownable. And what can you do with this now? So imagine then having this foundation, and I'm just going to open this semantic search interface, which is a very simple, familiar interface that you probably are very familiar with from Chat GPT and all the other AI tools that have recently became so popular. But this one, the main difference between this one is that actually this interface uses the knowledge asset that we just looked at, and in this particular case, the actual knowledge asset around the leaflet. So imagine a patient being able to scan a pack of medicine, be led to this interface and be able to ask anything. And I'm going to ask, for example, what side effects are the side effects of Umacro? So we have two ways of getting results based on the knowledge assets, the connected knowledge asset that we had before. So one of them is purely extractive, which means that based on vectorization, I'm not going to go into that. Branimir will talk a little bit about that later. Essentially, this search pulls out from the knowledge assets, from the relevant knowledge assets, everything around the side effects of Umacro in the form as it is displayed in this case in the leaflet. So you can see everything around, this is exactly the content that is in the leaflet that talks about possible side effects and some additional things that are related to the side effects themselves. Now, the really cool thing that we can do with this now, so we have this trusted extract. We know that this hasn't been modified. We know that it's true. Or we know where it comes from. We can actually then combine this with different AI models, such as, for example, OpenAI's LLM, or if you have, as an organization, an internal LLM model that you want to then actually feed this into and do different things. So we have in this this demo example, we have extract and summarize, where if I can now ask the same question, and I'm just going to copy it so I don't type again, we can ask the same question. And what will happen is that this trusted extract that we see here will actually be fed to the OpenAI, in our case, LLM, and you will get a slightly different answer because obviously we're combining extractive and generative AI. So this one will take a little bit longer, just because it's using the API, and here we can get a more actually concise answer that is essentially using this as an input to summarize. Now, with both of these extract and summarize modes, we can see that we actually can see where the content came from. So we have verifiability of data. We see, in this case, it's just one knowledge asset, but the query can be across 100 knowledge assets. You will know where it comes from. You will see the owner. So I can click on this. It will actually load the knowledge asset that we just looked at. So over here, it will you can do all of the things that we looked at before. So check the ownership, check what was going on with the knowledge asset, and everything else around the verifiability of it, and really be sure that you have a trusted infrastructure that is powering the AI system that you're using. And this is where I would actually end the demo, and I'm sure Branimir will have some things to add that I might have missed. But it's really exciting to be now able to, see into the knowledge graph and explore it and see how all of these assets connect, and how they can power different AI systems. So I'm going to stop sharing now.
That was great, Yuri. And yes, I mean, I'm going to jump right in with a couple of more slides. But essentially, what Yuri has shown now is really a couple of interfaces. The DKG Explorer being the one that's going live today, the one with all the beautiful graphs, and you can go and explore and play with it very soon. And the other interface was actually just one example. And the important example here being is you can do all kinds of different things with knowledge assets because of their basically the properties of discoverability, where you can find the answers from a knowledge asset. Verifiability, because you can verify that a certain source or provenance of information was involved. And then you can also basically be one of the owners, because this information can be composed this huge knowledge graph, we can compose it all together, such as, for example, Wikipedia was composed by a lot of volunteers and actually won over projects that were, for example, like Microsoft Encarta was like the big one back in the day. If somebody remembers, Wikipedia won. I'm curious to why. Maybe because it was open and let people collaborate and contribute, I suppose. But anyhow, long story short, this was just one example interface, and it showed this extractive knowledge answering. So when you do the same with ChatGPT, essentially it's generating an answer, and it can hallucinate, and it can make a mistake. It doesn't happen all the time, but if you're going to do a medical case, or if you're going to do any type of enterprise case, and it does that, I don't know, in 0.5% of the time, you're going to get in a lot of trouble. So it's not so easy to go in that direction for enterprises in particular, because essentially when ChatGPT or any such system, generative system, hallucinates, it generates misinformation. So you can actually go and check out the webinar we had last week on trusted AI in medicine, which we did together with Google, BSI, and AstraZeneca, and UMaker, the guys who we crafted this demonstration with. And you can check out all about that and the details about how the actual industry sees this problem. What we saw today, though, is not generative, it's extractive. So it goes into knowledge assets and it acts like a search, basically discoverability mechanism. It finds the answer that was on the leaflet. So there's no generation, there's no additional room for error that you can get with generative system. While the second example that Yuri showed, which was the summarization, extract plus summarize, actually takes that extracted answer and feeds it to a neural network and asks it just to summarize it. Obviously, when you include the generative component there's some chance of introducing some additional error. Then whoever's building such applications need to take care, be very careful regarding this. But it's also possible, and once you feed the neural network with something that is already predetermined and trusted as input, the actual problem is vastly minimized. And this actually is something which we're very keen on exploring through R&D at OriginTrail lately, which is really this relationship between symbolic and neural AI. Essentially, symbolic AI is this knowledge graph branch of AI, what you can see here on the left. And essentially, knowledge graphs are actually the embodiment of symbolic AI, which has been in development much longer than neural AI. And a lot of interesting, exciting technology came out of this, including the semantic web, which was the actual original Web 3.0, which was coined by Tim Berners-Lee, the inventor of the World Wide Web. So essentially, this technology has been expanding and growing over many years, and OriginTrail employs all of the standards basically from that technology. We haven't invented anything new. We basically took all of this great stuff that people have been building for a very long time. And what's really cool is when you take this symbolic approach and combine it with the neural approach, when you create essentially vectorized embedded representations of knowledge. And that can be used in many different ways. For example, what you saw just now with this UMaker question answering system, what we've done is actually we've taken the graph, the knowledge assets of UMaker and actually created this embedded representation where we've actually done a semantic search on top using basically a machine learning application. So you can do all kinds of really, really interesting synergies between these two technologies. This was just the basic one, essentially the most simplest one. And we see basically the knowledge assets becoming a substrate for trust and building essentially the armament of trust in the essentially decentralized system of AI that's growing and is built with both neural and symbolic AI. Having that said, as the OriginTrail ecosystem, we are together developing a very interestingly named framework called ChatDKG, which is an open framework where the idea is that we provide tools to both create and as well as use trusted knowledge, which is AI ready. So you can check all about it in more detail. And so far we had 3 developer calls So they're all on YouTube, and you can all dive deep into it. I'll just summarize it very quickly. What we want to essentially enable is that going all the way from the data sources, be that open data or personal information, such as, I don't know, for example, wearable information, or some other personal information, AI training data, enterprise system, for example, medicine information or supply chain information, whatever the data source, essentially we're looking for tools that move this data into knowledge, into AI-ready knowledge in this middle layer, where we essentially see these two different components. Knowledge bases can be centralized or decentralized, and indexing infrastructure, which can also be centralized and decentralized. And you can basically benefit from both when you create knowledge assets out of either centralized or decentralized knowledge, effectively then creating interfaces between AI and knowledge. So components which are built with models, such as the ones we showed you just now, or agents. AI agents are really, really hot topic lately. And then on top of that, obviously building all kinds of different AI solutions. The idea being that through the Chat DKG framework, we make it easy to do so and create the both knowledge assets as well as solutions and libraries that you can then use to essentially make it easier to create and manage and use trusted knowledge in AI applications. Chat DKG has been actually going on for some time, so you can already, like I said, explore a couple of calls that were that have happened, and they happen on a frequent basis, usually around every 2 weeks. So you can join the next one. The fourth one is just around the corner. What it's about is essentially about creating technical tools based on knowledge assets and AI. It's there to establish the best practices for discoverability, accessing, and querying of trusted information with AI tools. And the idea is, together with that, to create a trusted open knowledge base through the project as well via crowdsourcing knowledge. So you can find, like I said, all about that on ChatDKG, and the website is chatdkg.ai. With it together, there's a 1 million track token grant program for builders who are looking to build within trusted knowledge-based AI. So I encourage anybody interested who hasn't seen this yet to hop on this link, ChatDKG.ai, which you can also access by scanning the QR code, and join us in building all of the tooling and the exciting applications on top of OriginTrail and with the ChatDKG framework. To finalize that, we're going to quote our really loved advisor, Bob Metcalf, who said that said what you're seeing on the screen, that we're in a time of abundant connectivity, but also abundant misinformation, and that OriginTrail DKG is the tool that's rapidly evolving and for finding truth in knowledge. So he's a big supporter of the project. He's, like we said, the formulator of Metcalfe's law, and with Metcalfe's law, which says that the growth of a network actually being linear in numbers, the bigger a network, for example, a network of knowledge assets, the value of the network grows with the square of the number of participants in the network. We invite you to also join us, create your own knowledge assets, build applications on top of knowledge assets on this open source permissionless system. Share your ideas, join us in Discord and Telegram, and start building together with us, so we can basically leverage the Metcalfe's law and grow the value immensely for all of Web3. So join us and check out DKG Explorer at this new address, dkg.origintrail.io. Explore the examples you find there. If you happen to run into a bug or some idea that maybe it's not a bug, maybe it's an idea for improvement, also please drop us a line. We'd love to see that. It will be super helpful to get feedback from the community in the widest possible sense. And I guess this is where we close it for today with a quote from late Robert Noyce: "Knowledge is power, knowledge shared is power multiplied." Thanks, everybody, and we hope you enjoyed the new DKG Explorer, and and have fun with knowledge assets.
Maybe
Once
just
again,
one
join
last thing
us.
here. Oh, sorry, Bruno, I just wanted to say, if somebody is running into, we're removing the credentials now. So if it's takes a minute or two, just come back to the URL. So dkg.origintrail.io should be done in the next minute or two. Happy to hear your feedback. It's really cool to play to understand how knowledge assets work, how they're connected, where the power comes from, and happy to, like, if you run into any issues, as Branimir said, then just drop us a line in Discord so we can have a look. But this is just the first iteration of many exciting things to come. So stay tuned.
Thanks, everybody. Looking forward to your feedback. Have a great rest of the week and see you